So hello guys, welcome back to my channel. So next thing we are learning is probability. Probability is also important for the prediction, like what are the outcomes. In the machine learning we have to predict the outcome. So this is the probability which you have to learn for the machine learning. This is very important. So the first thing is probability is a measure how likely the event can occur. So this is like how likely the event can occur. This is called a probability. Like for example, the probability means desired outcomes divided by total outcomes. So probability must be what we are desired and total outcomes. For example, rolling the dice. This is the like for by getting the 2 means 1 by 6. Like you have to have the 1 2 divided by total outcomes are 6, like that. So the next thing is in probability, the next thing is terminologies, which are that random experiment means we are doing the experiment. Sample space means total, like in dice 6 are sample space, like that. And event means which will occur, like 1 by 6 will occur, no, that is event. So the next thing is this is over. And the next thing is joint event and disjoint event. Joint event means out of 100 students some are common. Disjoint means both outcomes are different, like that. And the next thing is probability distribution. In that, probability density function, normal distribution, central limit theorem. We are not solving here examples, but the functions which are important for the machine learning, we are learning that. So this is the probability distribution terminology. Let's see one by one after. So probability distribution function. In that, the equation describing a continuous probability distribution is called means continuously probability changing. Like see here, graph of this is there continuously over range, like from A to B this is there, -4 to 4 it is there, are bounded by a x curve function and x-axis is equal. So probability that a random variable assume a value of between A and B, and like area under PDF is bounded by, like if you want to find the probability that is in between A and B, and the area is must be in between A and B, this is called probability density function. So density is there in between A and B. This is called probability distribution function, PDF. The next thing is normal distribution. Normal distribution means probability distribution that associated the normal random variable x with the cumulative probability. Cumulative probability means, see, like here your I is not equal is a normal distribution variable. So yeah, here I is not equal is the normal random variable, and mu is the mean. So here, and sigma is the standard deviation. So see here, mean is I will discuss this in like in the statistics. So don't need to worry about that, but this is the formula for the normal distribution. Like see here, these are all, mu are also all the means, and sigma means that is the standard deviation. So this is the formula to calculate the normal distribution. You can write it down, and we will discuss mu and sigma all in the statistics next video. The next thing is normal distribution. Here already discussed this. Yeah. So the next thing is mean and standard deviation. So mean means determinants of the location of the center graph, and standard deviation is height. So basically this is the, if standard deviation is large, the curve is short. So standard deviation is having the large amount of value, the curve is the short. And if standard deviation is small, then curve is tall and narrow. So how it is, curve is depends on the standard deviation. So standard deviation is large means vice versa, like curve is short and wide it is, and if standard deviation is small, then it will go like tall and narrow. So like central limit theorem states that sample distribution of mean of any independent random variable will be normal or nearly normal if the size is large enough. So see, the sampling distribution of the mean any independent random variable will be like variables distribution, sampling distribution of mean is normal if the size is large enough. So here see, first n is equals to 1. This is one graph and see n is equals to 3, n is equals to 10, and after reaching the 50 it will become like whatever you want large, so the distribution is large. So it is the mean is depend on the size, like see n is equal to 50, then the mean of the independent variable we can find random variable, yeah, like this. The next thing is types of probability. One is marginal probability, one is joint probability, and one is conditional probability. We'll see one by one. So first is marginal probability, means it is like probability of occurrence of if there is only single event occurs, like in die by throwing the die only one can occur, so that is one example. Another one is see probability of getting this 3 heart. So in that 13 it will from the 52 hearts are 13, so like that. This is one marginal probability example, only single event is occurring. The next thing is joint probability. Joint probability is measure of two events can occur, like see in this example the probability that a card is an ace of heart. So there are 13 heart cards in 52 deck, out of them one in the ace of heart. So out of like 13, see here are two events are occurring, because we don't want only heart, in that heart we want ace. So from 52 we have to take 13, that is one event. Another event is we have to take ace, so that is another event. So two events are occurring, so this is like joint means two events will happen at the same time. And like for this uh, marginal, only one event is occurring, like that, only getting the heart. And here for the example is the ace getting. So conditional probability. What is the conditional probability? Means probability of an event or outcome based on the occurrence of a previous event. It will depend on the previous event. Conditional probability of B will depend upon the A has already done. So if A and B are dependent, then expression for conditional probability is P P of B by A. So A and B's probability divided by total A's probability. You are finding the A's probability. They are dependent on each other. So if they are independent events, so then the expression is P of B by A is equal to, means only P of B. We are finding for the P of A, so only P of B which is occurring. So they are independent. No, that's why P of B only. And if they are dependent, so P of A and B by P of A. We are finding for the P of A. We are finding for the P of A. So this is that. And probability in that Bayes theorem is very important. So Bayes theorem is nothing but conditional probability what you did, but something different in that. So P of B of A means is referred to likelihood ratio measure that the probability given event A of occurrence of B. So like A is dependent on B, like that is likely referred to measures the probability of occurrence of B. So uh, yeah, ratio of B comma A, that like that. P of A means referred as to prior which represent the actual probability distribution. This is like actual probability distribution of A, and this is actual P of B means actual probability of B. So P of AB means is referred to the posterior which means the probability of occurrence of A given by B, means first A has occurred, then B. So A given by B means after A which is dependent like B is dependent on A, like that. P of B of A means B is dependent on like sorry, A is dependent on B, like that. Okay. So the next thing is this is the Bayes theorem. Note it down, the formula. This formula you note it down. This is very important. P of A of B means A dependent on B of P of A divided by P of B. We are finding B. So that's why total whole by B, then P of B of A and P of A, like this. I explain all the terminologies. And Bayes theorem, for example, suppose you run a clinic where test if patient has a liver problems. In that prior probability that 10% of patients from before have a probability of A, means A patients are having 10% like liver problem, and in that probability patients drinks, let's say like 15% are drinks. So liver problem is dependent on the drink. If they drink, they have a liver problem, like that. So probability they drink even though they have a liver problem maybe around like 5%, like B is dependent on A. So whoever are drink, they will have a liver problem, like that. Liver problem is dependent on like B, like that. And the next thing, hence probability that that they have a liver problem is calculated by, like, see, first 0.05 means probability of A occurrence of B. So we are finding how much patients are having the liver problem, like that. So probability of B is 0.15, like 15% means 0.15, and the patients, like, see, probability of A of B means B means the parents who drink have must have the liver problem. So liver problem is dependent on B. So like, yeah, so this is 0.05 into 0.10, like the patients had a liver problem into the patients have may drink are having the liver problem, like that. So total liver problem divided by the drinking patients is equals to this, means whoever are having the who drink having the liver problem is 3.3%, like that. Three members must whoever visit the clinic uh, like liver problem, they are having must having the three members are having the liver problem. So suppose we are running the clinic, test the patient is liver problem or not. So liver problem, who are visiting the our clinic, in that three members are having the from 100 like three from 100%, three members are must be having the liver problem, like that. This is the Bayes theorem example. And the next thing is where this probability is used. So this probability is used in like optimizing the our model, like prediction. Yeah, for the prediction and classification by the algorithm, probability loss can also be calculated. So what is the loss and what is the profit, like that. And models are built on a probability. On probability is very important in that Bayes theorem and all, and some operations on probability, all that number of events. So sample events, joint, so the examples which are there. See, Bayes theorem is important, conditional probability is important, A is dependent on B, like that. And joint probability means two events. And the next is marginal probability, means only one single event, that is two events, and conditional is dependent on one another. And normal distribution, central theorem, and indence mean and standard deviation. And PDF probability, like from A to B, the probability distribution function. And the next thing is types of events, like single, like joint and disjoint event, terminologies, random experiment, sample event. You have to remember this all: sample space, random experiment, sample space, event. Yeah, these are the terminologies, and this is the probability. So the last thing is like one example of the code. Let's code here. So the next thing is, see, from sklearn import the data sets. We have to install the sklearn and matrix, like sklearn matrix and sklearn import Gaussian NB, and from that dataset dot load, and then Gaussian NB, and then model fit. So yeah, here expected data set, then predicted model, then matrices classification, then matrices dot confusion, except expected and prediction. So accuracy is 0.96, that is 150. And yeah, so yeah, expected data set target, that is the like this matrices. So we are printing the one is like expected and prediction, one is the confusion matrix. So this is the matrix which we are getting, and this is the like this is the accuracy what we are having, like 150, so maximum, that is. And this is the matrix we are getting. So this is, yeah, thanks for watching. This is over. So yeah, like, if you like, share, subscribe to my channel. And don't forget to comment below, learn, like, share, subscribe, and which next you want. I am uploading shorts and videos daily, so keep watching that. It will be helpful for your ML journey. Yeah, thank you. Have a nice day.